Good afternoon, everyone. Welcome to Bridging Open Data and Local Impact through Customized Dashboards for New York City Decision Making. I'm Rose Martinez, Assistant Deputy Director of the New York City Council's data team. It's my pleasure to introduce two data scientists who, for over a year or more, have been working on making two public data sets more accessible to council staff and members, Reese Hirota and Rachel Avram. Rachel has a background in behavioral decision sciences and has worked on several different projects ranging from public safety and transportation to developing packages in R and Python for the team. Reese is currently pursuing a master's degree in biostatistics and has worked on many of our housing-related data projects. I also wanted to mention a former data scientist on the team, Nicholas Montalbano, who has been pivotal in the kickoff of Maximizing 311, one of the dashboards here. So I'll let Rachel and Reese take it away, and they will be going over council count and Max 311, respectively, and they will be giving an overview of the council's goals and challenges around public data, and they will walk through each of the dashboards.
The New York City Council data team has developed data dashboards to transform large public data sets into accessible, actionable tools for the City Council. Council Count, which Rachel will be going over, helps the user understand and explore census data at your desired administrative or political geography. Maximizing 311, which I'll be talking about later, displays the past 5 years of 311 service requests by council district and detects anomalies in recent complaint trends. Both of these dashboards are created through our internal page for council staff, Dashboard Depot. First, we'll be going over council count. Rachel will walk through key features, data, methodology, building the dashboard, and getting the dashboard ready for users. Then I'll talk about Maximizing 311, where the data comes from, key features including anomaly detection, and the dashboard development process. Then we'll go through a live demo, and at the end, we'll have time for Q&A. If you have questions along the way, you can put them in the chat, and we'll get to them at the end.
Okay, hi everyone. I'm Rachel Avram, and I'm going to be talking about the dashboard that I built, which is called Council Count. This is just a little snapshot of what it looks like. We'll be doing a live demo later, and I'll be showing various screenshots so you'll get a sense of what it looks like and what the final product was. But the purpose of this dashboard is to make exploring the city's diverse population more simple and accessible at the tip of people's fingertips. What we do at the City Council data team is to bring evidence and data analysis and science into the policymaking process. So it's very important that we find ways to make data that can be involved in policymaking decisions more accessible and understandable to our stakeholders, which would be lawmakers, policy analysts, legal counsel, etc. Just a little bit of a project timeline and a background for why we decided to make this dashboard. Since we are a data team for the City Council, we get a lot of requests at the council district level to understand various demographic and social numbers to get a sense of what's going on in the city and where in terms of the population. We would get a lot of requests for different data at the council district level, which in most cases is not readily available. So we would have to come up with estimates for how to generate numbers. But as a team, we didn't really have one method that we all used to generate these estimates. So we decided that we needed to have one streamlined method for how we generate these estimates and then make them easily accessible to users. Our initial idea was to combine the Pluto data set with census data. We initially wanted to use BBL level data from Pluto, which I'll discuss later. BBL is a borough block lot, and it's basically the building level. We wanted to combine that with PUMS data, which is from the census, which also allows for cross-tabulation, but it comes at the PUMA level, which is basically an area that has about 100,000 people. When you're looking at demographic data at the 100,000 people level and trying to bring it in smaller, we found that it was quite unreliable and a lot of the data, the estimates were incorrect. We did want to rely on PUMS because it allowed for cross-tabulation, which would any combination of different demographics, such as males aged 18 to 24 who have a median income below 50,000. So you can get as granular as you would like. The problem is that it was only available at too high of a level. So we ended up landing on using the ACS 5-year data, and that meant we had to give up cross tabulation, but we got more reliable estimates. I'll talk more about our methodology later. ACS 5-year data is available at the census tract level, which is about 2,000 people. So a big difference from the PUMS data set. Now that you understand a little bit of the motivation for why we wanted to have this data available and at the specific boundaries we wanted them at, I'll walk through some key features of the dashboard. There's a navigation menu at the top. You can see there's a few different tabs that you can look through. Then here on the first page, this is map view, and it creates a choropleth map, which shows the distribution of a particular demographic group around the city. As you can see, using that key up there at the top, if the region is darker, it has a higher number, and if it's lighter, it has a lower number. We have drop-down menus to control the output of the choropleth. You can see the demographic selected is Hispanic or Latino. The geography is council district. And we did originally make this for council district estimates, but in the drop-down menu, there are about like maybe 8 or 9 other geographies we decided to expand it to, some of which do take estimates directly from the census hierarchy, such as neighborhood tabulation area and borough. But we also have boundaries that do not fit neatly into the census hierarchy, which is where this is a really powerful tool to give estimates that don't necessarily exist anywhere else. So we have things like council district, police precinct, community district, etc. For the time period, that's just the 5-year ACS time period. And then the measure would be percent. It's percents versus raw numbers. And then at the bottom, there's a regional comparison table that allows for more granular comparisons across the city rather than that sort of bird's eye view that you see on the left. This is table view. As you can see, the drop-down menus are of a similar format, but this is on the left, a different way of exploring the data. It is showing 2 different regions, in-depth comparison on many different demographics rather than just looking at one demographic around the city. This is good for comparing 2 regions. We wanted to have multiple different ways that the users could interact with the data depending on what their needs are. As you can see this, instead of using individual demographics, you select an area of interest. You can see on the right side for select areas of interest, this category is age. This is comparing Council District 1. We're using 2023 boundaries to New York City as a whole, using percents for different age groups. In the difference column, you can see how Council District 1 and New York City vary in these different categories. I know there's a lot of numbers. There's also categories for margin of error and coefficient of variation, which is used to make the users understand how reliable their estimates are and whether or not they should be more or less confident in sharing these estimates with others or using them to make decisions. Then the final option that we have available right now is chart view, and this is meant to show trends over time, comparing our estimates from 3 different ACS surveys. You can see 2007 to 2011, 2012 to 2016, and 2018 to 2022 as an attempt to show how things are changing over time. Take public transit to work. The percent of workers 16 years and over that take public transit from Manhattan. You can see that there's been a little bit of a fluctuation in recent years. So yeah, I'm just going over the different ways that we take the estimates and then make them presentable and are able to manipulate by the users to get the output that best suits their needs. We also have an about page, which I would recommend whenever you're making a public-facing or user-facing dashboard like this, with in-depth descriptions of how users can take advantage of the dashboard. They can go here if they have any questions, indicate who they can reach out to if they have further questions that aren't covered in the about page, just to make sure that the user experience runs as smoothly as possible. Hopefully their questions would be answered on the about page, but then giving them another avenue for asking questions if they need. A little bit more background about the data, the open data sources that we've used and tried to combine and make digestible to our stakeholders. So background about the 5-year American Community Survey. It's an annual survey that is sent out to 3.5 million addresses. So it's a sample of the total US population. It's not the same as the census because the census happens every 10 years and it is supposed to go to every address. But this is just a sample that allows us to get information, estimates in between those census years. It collects detailed information about things like race and ethnicity, educational attainment, employment, income, and much, much more. There's a 1-year ACS, but there's also a 5-year ACS, which is a 5-year average for the time period that it represents. That's why our time period dropped down. We had 2018 to 2022. And the reason we chose the 5-year average is because it increases the statistical reliability of the data, especially for small population subgroups and regions with low populations. Again, the lowest, most granular level it's available at is the census tract, but it is also available at some larger regions as well. I would recommend anybody, if they want to access this data source, use Pygris, or I believe it's Tidy Census for R. Pygris is for Python. It pulls the custom estimates from the Census API. You can see that code block I have there is using get census from Pygris to access the ACS 5-year data profile API, and then inputting variable that you want to get year, then the level, putting in an API key, then it would be a pretty easy way to get access to that data, which is sometimes not the easiest to access for people who don't have the same, know how to navigate their API. We also used the primary land use tax lot output dataset, which is also called Pluto. As you can see, this is a snapshot of a little bit of what the data looks like from our open data website. This is a dataset that is produced by the City of New York that we use that was very helpful to us. It has columns for, at the building level, borough block lot, number of residential units, locations, much more information that we didn't necessarily use for this project, but could be useful to anybody else looking to understand building level data. And we downloaded this from the New York City Department of City Planning's website. So a little bit about our methodology, now that you know the data sources. We wanted to get an estimate of different demographics at desired geography level. We first created BBL population estimates. And because each BBL gets a latitude and longitude with it, it's a point estimate for population. To generate this estimate, we multiplied housing density by number of residential units. What that means is to calculate housing density, we divided the total population in a census tract by the total number of residential units to get a sense for every census tract, roughly how many people are living in each residential unit. Then we multiplied that by the number of residential units within one BBL, not to generate an estimate we would use for that BBL, because that would not necessarily be the most reliable, but to then aggregate up to much larger levels to get a rough estimate of, along any boundaries that we wanted to create, how many people live among those boundaries. But we would not want to use the BBL level estimate itself. It's to aggregate up to larger levels. And then, now that we had an estimate of how many people lived in each BBL in each region, we pulled the ACS 5-year percent estimate for the selected demographic in that census tract. Then we multiplied the census tract level demographic proportion by the BBL level population at a BBL level to get a BBL estimate for a point estimate, latitude, longitude estimate for the demographic in that region. Then we would aggregate to geographic boundaries that we desired that were matched to the coordinates of each BBL, and then get an aggregate level estimate of each subpopulation at a desired geography. Please let me know later in the Q&A section if you have any questions about our methodology, because I know that was a little bit of a mouthful. What came next after we wrangled our data sources was building the dashboard itself and getting the dashboard in a format that was usable and intuitive. In order to make the dashboard, I used Dash, which is a really powerful tool because it's written mostly in Python and you don't need to have much web development background. You can use other languages if you want, but it's not necessary. It's basically mostly just completely, if Python, that's enough to make a really useful, powerful dashboard. It has pre-built interactive components like drop-down menus, sliders, and graphs, and it integrates with Plotly. So it makes it simple to create dashboards in not too much time without much web development experience. Can also make it mobile friendly and responsive to window size. You can really do quite a lot with it. The way that we deployed it was on an internal server. Then what did we do after we created the dashboard? We wanted to make sure that it was thoroughly tested and met the needs of its users. Before we shared it with a wider audience, we asked other data team members, central staff, and district office staff to provide feedback as it sort of met their unique needs. and how they might have wanted to use it, what they would want to see, what things were confusing, what things could be improved upon. And then we worked on integrating that feedback to make sure that it was as improved as could be for the specific needs that we were trying to meet. And then we started sharing the dashboard with more stakeholders, in turn getting more feedback in real time that we were integrating. But we wanted to make sure that the intended audience was targeted with knowledge of the dashboard so that they could use it. So we held a lot of workshops and made sure that we spread information about the existence of the dashboard and then how to use it so that it could be a tool that people could take advantage of.
Hi, again, this is Reese, and I'll be talking about Maximizing 311, which is a dashboard we created to simplify the use of 311 requests for data analysis. The data for this dashboard comes from the 311 service request from 2010 to present dataset on the Open Data portal. 311 responds to thousands of inquiries, comments, and requests from customers every single day. This dataset represents only service requests that can be directed to specific agencies. As of right now, the dataset on Open Data contains 39.4 million rows. Each of these rows contains information about the service request, including complaint type, responding agency, and geographic location as latitude and longitude, as well as I also think council district is available. However, we use latitude and longitude to be able to group it into any geography. The data does not reveal any personally identifying information about the customer who made the request. Seeing as this is a very large data set, there's over 39 million rows, it can be difficult to work with. So we created a dashboard to simplify this process for our staffers. Requests can be submitted online at the 311 portal or by calling 311. This is what you might see when a user is entering information to report to the online portal. And then this is what you'll see on Open Data if you try to access the data set. So this is the data I'm pulling monthly to update the dashboard. How I do this is I've set up a cron job and it uses the system time of the computer. So every first of the month, it'll pull the data from the past 5 years, and that'll keep it refreshed and getting that new month every month. Now I'm going to talk about key features of the data set. This is what you'll see if you click onto the data set and just choose to load all of the complaints from the past 5 years. There's some drop-down menus on the sidebar to filter on start date, end date, category, complaint type, which is from 311, descriptor, which is also from 311. Then you can also choose up to 3 council districts to compare. So if you have a problem where you want to know if an issue is more prevalent in one council district versus another, that's how you can do that. This is a Shiny app to make it easily usable and editable with R. Right now you're seeing the map view, but there's also a view for the time series as a graph as well as a table. In addition to our overview tab, we also have a trends tab. This uses anomaly detection, which I'll talk more about in the next slide. It shows a 97% confidence interval based on the best fit of a series of models ranging in complexity. So you can see on this one, the latest date, which is December 2024 for the lead complaint, is highlighted red because it is outside of the bounds of the confidence interval, which is in blue. So we expected the number to be a lot higher based off previous months, and it was lower. So we would then classify that as an anomaly. This is the process for anomaly detection. First, we fit a set of models ranging from simple to complex. We then use the time series data to determine which model fits the best. Using that best fit model, we predict the next month's number of complaints. We're then going to create a prediction interval using its residuals on the 97% prediction interval. And then if the new complaints data is outside the width of that interval, just like we saw in the previous slide, we expected a lot more complaints and we got fewer, we would then classify that as an anomaly. So we take this and then we just show you it as a graph on the anomaly slide to make it easier to understand. There's a lot of ways that council staff can use this. You can look up statistics for committee reports. People have used 311 data in the past to figure out where the best place for a program placement might be. So it's important that we incorporate the feedback of people who will be using it. For the initial stages, as we discussed in the previous few slides, the initial design was tailored to make it as easy as possible for our staff members to interact with 311 data. And we refined the product internally by following up in project meetings. We then did beta testing. We reached out to a few common users of the 311 data to get their initial feedback. Then we did staff presentations. After incorporating the initial feedback, we presented our product to more general audiences to get the word out, as well as continuously incorporating feedback and refining the process. Feedback we've gotten so far is people are interested in more geographies, such as the borough level, which we can do with the 311 data since it's at the latitude longitude, as well as some things like being able to download maps that we might easily overlook in the development process were brought to our attention during our presentations. So before we get to Q&A, we're going to do a live demo. Rachel's going to show us something you can do with Council Count.
Okay, so here's Council Count in action. Let's think of a potential use case where we might need this information and how this could be helpful. Let's say that the government or the council is trying to find the best regions to advertise a certain program that is available to people from a certain income, let's say less than 10,000. Let's let that load. So you can see that these regions tend to have higher numbers of people who are in this income bracket. That would give council members a better idea of maybe which regions could be best served by this program and where they might want to target advertising. You could also press select all here to compare all regions to one another. Take a look at how all council districts stack up here. This is just raw numbers, but we can also look at percents and see if that really changes. It does change the map a little bit, so that's interesting information. Then quickly looking at table view, let's say we want to compare how one specific council district stacks up to New York City as a whole on income. So we go here, we click household income and benefits, and percents is a better way to compare two regions that have very different sizes. Instead of council district, let's actually just do borough. Maybe we're more interested in Staten Island. I'll take these away to make it a little bit easier to see the comparisons. And if there's poor statistical reliability, there will be a little asterisk. Back to map view, how to see if something is not reliable, it will be shown in gray. That could be probably because the population is really small. For example, American Indian and Alaska Native. You can see most of the regions are in gray, which means that the estimate is not reliable simply because there's a very small sample size. In cases like these, we would recommend that you go up to a higher geography level. You'll see that the estimates are now reliable. So one quick example of chart view, let's say we want to see how the population of those who are naturalized US citizens have changed over time, let's say in New York City as a whole. And let's click percent. You can see that it's increased. That is a little summary of different ways that you can use the dashboard. Here's the about page with a lot of in-depth information about how the dashboard was made and how to use it. Yeah, that concludes my demo.
Now I'll be doing a little demo of my dashboard, Maximizing 311. There's a lot of questions you can explore with 311 data. You can look at how complaints changed over time, how are complaints dispersed across the city, have there been unexpected increases or decreases in a specific issue using the anomaly detection slide, what are the top council districts for a specific issue, over time is this specific issue increasing or decreasing in this council district. I'll walk through one of these examples. We can do which council districts have gotten the most noise complaints in the year. To do that, I'm going to go over to my overview tab. For the past year, I'll do November 2023 to November 2024. You can use categories, but since I know the specific complaint I'm looking for, I'm just going to go to complaint and I'm going to type in noise. I'll select this one. You can see in the drop-down menu the types of descriptors associated with noise. There's jackhammering, loud music. So if you're interested in a specific type of noise, you can refine this even further. I'm just going to look at all noise, and I'm going to submit this request. We can see that it seems like most noise complaints are concentrated around like Lower Manhattan and this area of Brooklyn. You can scroll over the map. You can see the exact number of 311 requests for noise in that Council District 2 had almost 3,000. Council District 3 had a little more than 3,000. We can see it over time over the past year. And we can see it as a table. So now that I have this, maybe I'm interested in, it looks like 33, 3, and 4 have the most complaints. Maybe I want to compare them. And 4. Submit that. And now I can compare the exact council districts. We can compare the council districts. We can see 3, we can see 4, and we can see 33. We can compare these to each other if we wanted at any point in the year. In the trends tab, maybe I want to see if noise was anomalous. So again, since I know what I'm looking for, I'm just going to type in noise. I'm going to press submit, and we don't see that noise is anomalous. If you are interested in seeing only the things that are anomalous, you can click see anomalies only. It'll update the drop-down menu. You can see construction lead dust, for example, was anomalous this month. There's also a more info tab with a little bit more information about the dashboard, the data source, and a link to report 311 complaints. So that concludes the demo portion. Now we have time for Q&A.
All right. Thank you guys so much. I think the one thing people were asking the most was a link so that everybody can use it.
Yes, we're happy to share the links, I think, to anyone who reaches out to us. These are tools mainly to serve the council staff, but we're happy to share the links if you reach out to us, if anyone is curious in fiddling with them.
We have a couple of more questions here. I see Indiana says, can the search list be saved?
I can answer that for maximizing 311. We're currently updating it so that the table can be saved as an Excel or as a CSV, and a download button for the map as well. I think this would work for Rachel's dashboard also. Like a quick, easy fix for it would be to screenshot it, but we're making it easier to download specifically.
Yeah, for my dashboard, there is a button that allows you to download the entire data set that is associated with the year and the geography you have selected. And then also some individual tables and the line chart and stuff, they do have buttons that you can press that allow you to save them. So most of it can be saved. Even if you can't save an individual result, you can download the whole data set. I do have an option for that.
Nice. Okay, thank you. I see the next question is from Jay, who says, why haven't these tools been released to the public? Just curious. Not only because it's a great tool, but because I'm sure other city agencies can make use of both dashboards.
As a team, we have no problem in sharing it with the larger audience. The data sets we're using are public and open. The only sort of caveat there is that we wanted to first roll them out completely internally here at the council and incorporate more of the feedback before then spreading out to a larger audience. There's also been conversations of the council. Some staff have come back with the feedback of integrating it with some other private data sets that pertain to the council. If then that's the case, we're still contemplating, do we build another dashboard internally? So those are some of the new questions that are coming up. But if you are an outside group or agency, we have no problem sharing the link after you email us.
All right, thank you so much. I see one more question from James, who says, I may have missed this as I joined late, but what tool did you use to build the front end? And did you consider off-the-shelf products like Tableau or Power BI?
I can speak to how I built Council Count. Reese and I did use different methods for building our dashboards. I used Dash, which is a package that can be used in Python. And it's definitely the package that makes it easier for people who don't have as much of a web development background to make dashboards relatively quickly. There's a bit of a learning curve. You have to definitely figure out how to use it. But if your background is mostly in Python, I would say it's a great tool to build a dashboard that has a lot of awesome functionality and that looks cool.
As for me, I mainly program in R, so I use R Shiny to build the dashboard. I really like R Shiny because you can use a lot of other R packages like Leaflet. I use Leaflet a lot for maps, and it was easy for me to put that in R Shiny dashboard. I think one of the caveats of using R Shiny though is speed. You just have to be conscious about caching variables maybe because it can get a little slow.
To address the Tableau and Power BI options, since the team we do program in R and Python, we have the capabilities to develop these dashboards using R and Python. Tableau is an outside, we would have to probably pay in order if we wanted to use the full extent of Tableau's offerings, while we are not limited to that if using R and Python.
About the city council dashboard Rach presented, will there be additional demographic information on individuals with limited English proficiency with more language data per council district? I know the CEC and Open Data created something similar back in 2020, so an updated version with that data would be great.
Right now, there is an option, I believe, for I'm trying to look up the exact name of the variable, but there is something related to English proficiency. Okay, so there's a language category. It's speak only English at home, speak English less than very well, and speak Spanish at home. So maybe speak English less than very well would be what you're looking for. Right now, there's just a set number of variables. I didn't discuss necessarily where all the variables come from. They're all from the 5-year ACS. I have a little over 100 right now as just like what's set as the main list of variables that can be drawn from, but it is possible to generate new estimates if you're interested in something in particular. I am also developing a package that will allow for new estimates to be created on the fly using the same method. So if there's a specific variable you're interested in, you could reach out to us, but potentially speak English less than very well might be basically what you're looking for.
One more came in from Javier. Great presentation. One question. If you have to study and practice Python and R again, how would you start, or what books would you recommend, or what experts on Python and R do you follow or learn from?
I guess I can kick that off. I do have to say that with ChatGPT, Copilot, and sort of these AI tools that have come out can make it easier in the learning process. You could even ask ChatGPT what books or resources to use or to develop a lesson plan for you. I think that the easiest thing to do is think of what you want to do, or even through these presentations, a lot of people have shared their GitHub repos. It's to follow along and start tweaking things. I think you learn by just starting there and getting those error messages and going on Stack Overflow or ChatGPT to help you fix it. I think there's going to be a lot of that, so don't get discouraged when things don't run and you get all these errors and you don't know how to fix it. Everyone pretty much relies on Stack Overflow and ChatGPT to get unstuck. I'll let Rachel and Reese share more.
I feel like I was using Stack Overflow a lot, looking at the documentation for specific packages and functions. I think there's also the website Geeks for Geeks. They have a lot of good articles of like how to do certain basic things in R and Python. I would also emphasize using AI tools like ChatGPT is also helpful. And it's the reality that a lot of people are starting to integrate those tools into their coding work. You can ask, show me an example of how to make a function that does this, or show me the most basic example of code that would accomplish this task. That can give you a starting point that you could build off of by looking at the documentation. But I would say don't be afraid to use AI as a support tool or as a learning tool. Yeah.
I think DataCamp also probably has some free Python and R courses, and that might be a good start. It's a choose your own adventure beyond then, and then that's just a lot of Googling and maybe some ChatGPT.
Yeah, and there are courses on places like Coursera, but I do believe that those are not completely free. There's definitely going to be tons of websites out there that offer courses. So if that's something you do want to invest in, you could look there. But there's definitely a lot of free tools on the internet too.
All right, excellent resources. I actually have a question, if I may. So, for everybody that's asking to demo the tool and for all these other resources you guys shared, once they reach out to you, they'll be able to give their feedback based off of what they've used. And would you guys incorporate that a bit into regulations?
Yeah, well, we're happy to hear people's feedback, especially other groups who are looking to use them themselves. Like, who knows, maybe we have a public facing version and an internal version that are more or less the same, minus one or two things if there's any private information that we want to connect it to. So definitely.
Again, everybody, thank you so much for joining. Enjoy the rest of the day and the rest of Open Data Week.
Thank you.